Okay, I'm going to go through the practice test here for Unit 6. So first off, we're looking at several statements, and we want to look at these statements and say whether this is describing something exothermic or endothermic, or maybe either one. We're not quite enough information. So when calcium chloride dissolved in water, it warms up. Okay, if it warms up, that means the chemicals themselves must be releasing energy, okay, in order to warm up the surroundings. So the surroundings warm up, so that's exothermic. Energy is absorbed in a reaction process. Okay, energy absorbed, that's the definition of endothermic. Here we have energy on the left side. That's the same thing as saying energy is absorbed. So this is endothermic. And potential energy going from high energy to low energy. And if that happens, then energy is released to the surroundings. And energy released is exothermic. The reaction has a temperature of 200 degrees. Okay, it's not saying that it rose up to 200 or anything. It's just saying it's 200 degrees. That could be either one. And the Q is negative. Okay, negative is exothermic because we always do numbers as products minus reactants. And products minus reactants giving a negative value means the products must be high and the reactants are low. I just said that wrong. That the products are low and the reactants are high. So a small number minus a large number would give us a negative value. So that's exothermic. Okay, these kind of problems. Again, we need to say for each one whether it's true or false. And if they are both true, does the second statement explain the first statement? So an exothermic process has a high temperature. At first that sounds like that's true, but it's not always true. And a good example would be, let's say, ice put some water into the freezer. It is going to lose energy. That's going to be exothermic as it turns into a solid. So liquid turning into solid in a cold place. So it does not have to have a high temperature. Exothermic means that it gives off energy. Exothermic processes release energy. That is definitely true. So that's false and true. And so if we were to look on Earth, that would be a BC. The answer, false and true. When ice at negative 15 degrees is heated, initially the ice will start to melt. That is false. Okay, the ice will not melt until it gets up to 0 degrees, and that's like our heating curve. So if we're starting down here at negative 15 degrees, it has to warm up before it'll melt. So that's it. The heat added increases the average kinetic energy of the ice. Okay, so if you're adding heat, we're talking about this little slanty portion of the heating curve, and we're going to have a change in temperature, and a change in temperature, is average kinetic energy change. So this is true. So it's a false true. Again, it would be answer BC. In a reaction, A turns into B plus heat. Okay, so that's exothermic. Energy's on the right. And we know that the delta H reaction is going to be negative. We just mentioned that above. So this is going to be a true statement. Because delta H of B is less than the delta H formation of A. We were saying that the delta H's of formation is a way of talking about the energy of the reactants in the products, if we made them from their elements. So the reaction of B, turning A into B, is less. So B is low, A is high, downhill, energy given off. That is all true. So this is also true to the point where I say I think this is true, true, and it does explain. So I would call this TTCE, or in this number I'd say it's ACE. So true, true, and it is a correct explanation. Number 10, which of the following is true about the freezing of water? Okay, freezing of water. Okay, liquid going to solid, yeah, that sounds true. Heat is on the side of the solid, on the more solid side, so this is perfectly good. Q is greater than 0. Okay, if heat is released, that's going to be negative, so that is not true. And molecular attractions are weakened. Okay, solid is pretty strong attraction, so this is false. Molecular attractions are strengthened, so it's going to be one only, answer A. Okay, units for specific heat. So that's like the 4.18, and those are joules per gram degree. joules per gram degree, so we're looking at answer D right down there. For number 12, which of the following is true for an endothermic process? Okay, heat is a product. No, heat is produced for exothermic, so that's not an answer. Q is less than 0, that's negative. No, that's for exothermic. The reaction mixture may increase in temperature. Okay, if it's endothermic and you are going to absorb energy, then yes, it may increase in temperature. And the reaction releases heat. No, that's the definition of exothermic. So by process of elimination, we know the answer is C, and we think that just by the definition of endothermic, that's true as well. Now the reaction mixture, okay, the chemicals themselves, okay, would absorb energy. 13. A substance with a high specific heat. Okay, high specific heat means it has a great resistance for a change in temperature. So it looks like D requires more energy to raise the temperature than a substance with a low specific heat. That's true. 14. Which of the following is an example of an endothermic process? Well, combustion, releasing heat, no, that's exothermic for sure. Dissolving calcium chloride, which feels warmer, no, that's exothermic. As it dissolves, it heats up the surroundings. The freezing of water, so we're talking about liquid changing into solid, freezing, and we said heat always goes on the more solid side, so that's going to be exothermic, so that's not the answer. So it better be D. The vaporization of ethanol, and that makes sense. Vaporization is liquid going into a gas, and we'd have to put heat into the liquid, put it on the more solid side, to turn into a gas. Okay, that's a G for gas. So the answer is D. Okay, 15. 30-gram samples of liquid ethanol and water are heated at their respective boiling points. Which sample will take longer to vaporize completely? Okay, the delta H of vaporization of ethanol is 200, and for water it's 500. These are in calories, that's okay. So we can see that this one here, water is going to have a greater resistance to change, so water is going to be our answer. That will take longer to vaporize, so the answer is B, water. Which of the following is the correct equation for condensation? Condensation, okay, if we're going to condense, that means we're going to go from a gas to a liquid. So gas to a liquid, so it cannot be this answer, okay, liquid to gas. No, that's going to be vaporization. Gas to liquid. And then we know that heat goes on the more solid side, so it's on the liquid side. So that one's wrong. So the answer is D. Water gas turns into water liquid and releases heat because we are strengthening our interactions. 17. Which of the following takes place initially when heat is added to a block of ice at 0? So if it's at 0, that means it's ready to be melted. So the temperature is not going to increase because we're going to hit our little plateau. The ice will melt, that's true. And molecular attractions are strengthened? No, if we're melting, we are breaking those attractions. So it's answer 2 only. Answer B. For 18, which of the following portions of the heating curve is the substance changing state? Okay, we know that that happens at the little plateau areas. Okay, either things are changing temperature or they're changing state. So it's segments 2 and 4 only. Answer D. 19. Blocks A and B are made from different metals and have the same mass. When they are heated with 500 joules of energy, block A increases 15 degrees while block B increases 90 degrees, which has a larger specific heat. Well, he says specific heat is the resistance to change in temperature. So if block A only changes by 15 while B changes by 90, then A has a larger resistance to change. So it's block A is the answer. When 20 grams of a metal is heated with 140 joules of energy, the temperature increases from 20 to a 50.8. Which of the following could be the metal? Now the way we're going to identify is looking at values of C. So we're going to use our equation that Q equals MC delta T. But in this case, we are given the Q, so it's 140 joules, and we are given the mass, that's 20 grams, and we are looking for C, and the delta T is going to be 50.8 minus 20, so that's going to be 30.8. So we have to solve for C. So C is going to be Q divided by M and delta T. That's kind of sloppy. So C is equal to Q over M delta T. So if I calculate that out, I get 0.227, that's 10. So the calculation is 140 divided by 20 divided by 30.8. For 21, what volume of H2 at STP reacts if 155 kilojoules of energy is released? So we have 155 kilojoules. And then we have this conversion that says we have 310 kilojoules for every 1 mole of reaction. And we know for every 1 mole of reaction we get 2 moles of hydrogen. And we're trying to get volume, so the last part is we have to say times 1 mole of hydrogen is 22.4 liters of hydrogen. And when we do all this, now this is energy is released, so that's negative, and because it's on the right, that's negative. It's going to work out the same. So when we get all done, we can see it's going to be 2 times 155 looks like 310, and 310 divided by 310, that is going to be 1. So the answer should be 22.4 without a calculator. Okay, 22. The delta H of reaction is 572. Find the bond energy of the OO double bond. So we know that what's going to happen, the delta H of the reaction is going to be the energy of the bonds broken and the energy of the bonds formed. So what do we have? We have 4 OH bonds, that's broken, and we have 2 HH bonds, and we're going to form, I'm sorry, that's wrong. So HH bonds are formed, so we need the positive value of that one. That change the sign on that one. And we have one X, oxygen bond, we'll call that X. So what we're going to say is that 4 times 467 plus 2 times the negative of this, so negative 432, is going to equal X, and X is going to be the opposite of the number that we want. So when we work all that calculation out, we get 432 as our answer. 23. What is the value of delta H of reaction for the following reaction? So it's going to be 2 times the nitrogen's number, okay, plus 5 times oxygen's number, minus 2 times N2O5's number. Well, what is the value for the following reaction? Okay, this is going to be 0 energy, and 0 energy minus 2 times that number. Okay, so that number is negative 42, so it's 0 plus 0 minus 2 times negative 42. So minus 2 times negative 42 would be positive 84. Answer C. For 24, consider the following reaction. We have this reaction. If 65 grams reacts, 72 kilojoules of energy is released. What's delta H of the reaction? So we know that delta H of the reaction is going to be Q over N. Now Q, we can see, is 72 kilojoules. And that is released, so we'll make it negative. And then we have to get moles. So we have 65 divided by 208 grams per mole, and that is 0.3125. And if we work out that calculation, so 72 divided by 0.3125, I get 230. So it's going to be negative 230 kilojoules per mole. 25. When 1 mole of aluminum chloride decomposed, 290 kilojoules of energy is absorbed. Which of the following represents this process? Okay, so we're saying 290 kilojoules of energy is absorbed. That means we need energy on the left-hand side, so we can eliminate these two answers. 1 mole is 290, so if we have 2 moles of aluminum chloride, it must be double that, so the 580. So this is the answer, answer D. Those are all the multiple choice questions.